Have you ever considered that the tiny building blocks of everything around us, including you, might not just be particles but also waves? Matter particles have a de Broglie wavelength because, fundamentally, all matter exhibits wave-particle duality. This concept, proposed by Louis de Broglie, suggests that particles like electrons, protons, and even atoms are not solely particles but also possess wave-like characteristics. The core mechanism behind this is rooted in the universal nature of quantum mechanics. Just as light, which we often perceive as a wave, can also behave as a particle, a photon, de Broglie hypothesized that matter particles, traditionally seen as discrete entities, must also have associated wave properties. This wave-like behavior is directly linked to a particle's momentum, which is a product of its mass and velocity. The smaller and faster a particle, the more pronounced its wave nature becomes, aligning with quantum principles that govern the very small. Understanding this means we can actually calculate the wavelength of any particle. The de Broglie wavelength is determined by dividing Planck's constant by the particle's momentum. So, for a macroscopic object like a baseball, its mass and velocity give it such a large momentum that its wavelength is incredibly tiny, for too small to be observed or measured. This is why we do not see everyday objects diffracting or interfering like waves. This intriguing concept isn't just theoretical, it has been rigorously proven. The Davison-Germer experiment in 1927 provided the first experimental confirmation, showing electrons diffracting just like X-rays. This wave property is also what makes technologies like electron microscopes possible, allowing us to see incredibly small structures for beyond the resolution of optical microscopes by leveraging the wave nature of electrons. It is a cornerstone for understanding quantum phenomena. Ultimately, the de Broglie wavelength reveals a profound truth about our universe. Everything, from the smallest electron to the largest galaxy, has an inherent wave nature. While only perceptible for microscopic particles, this wave-particle duality is not just a quirky quantum effect but a foundational principle that reshapes our understanding of reality, paving the way for advanced technologies and deeper scientific inquiry.
If quantum tech fascinates you, like, subscribe, and keep exploring with us.